Sorry, folks online, I was muted. We'll start. Hello and welcome to NOAA's National Ocean Service Science Seminar Series. My name is Tracy Gill and I'm the coordinator for the seminar. Today is the last of 4 seminars in the 2019 NOAA Science Seminar Report Series, and you'll hear more about it after the seminar logistics. We have 4 speakers today. You can type your questions into the chat at any time. We will not get to them until after all speakers have presented. To see a larger version of the slides, you can go to an expanded or larger view by hitting the 4-arrow icon in the upper right of the slide deck. This view can be toggled on and off, either using that button or escape to get back to the chat box. If you are interested in getting a PDF copy or MP4 recording of today's presentation, please contact any of the 4 people listed in the chat box at NOAA.gov and we will be happy to send you a copy. And if you are not on NOAA's weekly science seminar list but you'd like to be, go ahead and contact me at tracy.gill@noaa.gov and I will add you to the list. And now I'll turn the floor over to Emma Kelly, a program analyst for NOAA's Office of Atmospheric Research, supporting the NOAA Research Council. Emma will introduce the NOAA Report Seminar Series, the hosts, and today's seminars and speakers. Emma?
Thank you so much, Tracy. All right, welcome everyone to this 2019 NOAA Science Report Seminar on a sample of 2019 research accomplishments, including for social science. This is the 4th and final seminar for the inaugural NOAA Science Report Seminar Series. The sponsors for this series include the NOAA Research and Development Enterprise Committee, Gina DiGiantonio, Laura Newcomb, myself, and of course the NOAA One Science Seminar Coordinator, Tracy Gill. The NOAA Science Report is an annual report that highlights NOAA's scientific accomplishments for the year. The report celebrates NOAA's research and development in 4 sections: Introduction, Science Highlights, Bibliometrics, and NOAA Scientific Workforce. Together, these sections highlight how NOAA's research products impact the lives of all Americans. The 2019 NOAA Science Report was released earlier this month and is available at the link provided in the slide you are viewing. I think it's the next slide. There we go.
Hi, Emma?
So there, yeah.
Emma?
Yep.
Are you there? Some people are having a hard time hearing. Is there anybody online who can hear? Could anybody hear Emma, if you could just get back to us? Oh, okay. So some people are hearing. Thank you. Folks online
I'll try to speak up more.
Well, many people can hear, but folks online, if you can't hear, you can go up to the microphone icon at the top, hit that pull down, or your speaker icon, hit that pull down and increase the volume on your speaker. You can also do that in the lower right of most computers. Okay, go ahead, Emma. I'm sorry to have interrupted you.
No, thank you, Tracy. Yeah, if anyone can't hear, please speak up and I'll try to speak a little louder. So to continue, the report spans, the NOAA 2019 Science Report spans the entire range of NOAA's mission, and there are 64 stories featured in the 2019 report. Today, we welcome 4 speakers whose work is featured in the Science Report highlight section. Our speakers are Dr. Jennifer Henderson, who is a social scientist who received her PhD in Science and Technology Studies at Virginia Tech and completed a postdoctoral fellowship with the Cooperative Institute for Research in Environmental Sciences, CERES. As a CERES research scientist, Dr. Henderson works with stakeholders in the weather and climate communities to co-produce knowledge about the communication of risk and uncertainty in predictive information contexts for weather and climate extremes. Dr. David Dubois received his BA in physics at Rutgers University, his MS in physics at New Mexico State University, and PhD in atmospheric science at the University of Nevada, Reno. As the state climatologist for New Mexico, Dr. Dubois focuses on climate literacy through providing climate information to the public, speaking engagements, interviews, school demonstrations, networking, and tours. Through his faculty appointment at New Mexico University, he maintains an active research program in air quality and applied climatology. Kara Salazar has a BS and an MPA from Indiana University's School of Public and Environmental Affairs and an MS from the Indiana University School of Education. Additionally, she is pursuing a PhD part-time in Natural Resources Social Science at Purdue University. Kara Salazar is an Assistant Program Leader and Extension Specialist for Sustainable Communities, affiliated with Illinois-Indiana Sea Grant, Purdue University Extension, and the Department of Forestry and Natural Resources. Working with multidisciplinary teams, she develops programs and resources to support planning and sustainable development strategies in communities across Indiana and Great Lakes states. Dr. Alan Haney was an undergraduate in economics and international relations at Stanford University and was a NIMS Sea Grant Marine Resource Economics Graduate Fellow at the University of Washington, from where he received his PhD. Alan is currently an economist at the NOAA Alaska Fisheries Science Center, and his research includes the spatial analysis of fisheries under changing climate, biological and market conditions, and with the implementation of catch shares and other management changes. Each of the 4 speakers will give a 10-minute presentation, and then we will have a question and answer session at the end. All right, so next I'll hand it over. Take it away, Dr. Henderson.
Thank you so much. So I appreciate this opportunity to be here today to share our work with you. I wanted to acknowledge my co-PIs, Julie DeMuth and Jennifer Spinney, who have been wonderful throughout this research process and also in helping me with this presentation. And today I'm going to talk about the methodology of our project, a social science deployment. For those of you who are familiar with IOPs or intensive observing periods, this is kind of an analogous project to that. It's something that physical scientists call their fieldwork deployments. So we're doing something very similar. Our grant has the following objectives. This is part of to build knowledge and conceptualization, propagation, and communication of confidence and uncertainty in 2 tornado events through ethnographic observations at a national center, a local National Weather Service forecast office, and a local emergency management office. And to accomplish this objective, we've designed methods that allow us to approach the problems of confidence and uncertainty in unique ways, and I'll talk more about that today. So I wanted to start with this slide. Why focus on methods? This cartoon shows an elderly grandfather sitting next to a younger man on a park bench, and he's answering a question, the grandfather is, and he says, "I'm not sure what methodology they use to determine he is the world's best grandfather." As this cartoon suggests, methodologies can sometimes be, about a particular problem can be taken for granted or black boxed. Yet methods are at the heart of what we do as researchers, and they shape the data collected and the kinds of insights that we can gain. So as I hope to show today, methods are not as straightforward and simple as they might appear, especially when they involve relationships built with collaborators across the weather enterprise. And ethnography is our foundation of our methodology here, and you can see that an ethnography is, according to this anthropologist Marvin Harris, literally a portrait of people. It's a written description of a particular culture, the customs, beliefs, and behaviors based on information collected through field work. And it's, as I said, the foundation of our social science deployment, and it's posed interesting opportunities and challenges that I wanted to highlight throughout this presentation. And in particular, we have an ethnography that's built on triangulated data collection and a building of trust, and those are 2 seminal pieces of this method. So in our observations, the researcher is equivalent to the instrument, watching people in their naturalistic setting, capturing written field notes and thick descriptions of what they observe. They may also participate in the community at different times. We combine this with interviews that can be both conducted pre- and post-observation in formalized mode, like semi-structured interviews, or that might be more what's happening in real time as follow-on and follow-up to discussions or observations that we see in the field. And then finally, we combine this with discourse, which is a collection of materials, texts, visual forecasts, warning products, public brochures, policy documents, a whole host of materials that we collect. And we triangulate this information together across those 3 sites in order to build our theory. So as you might expect then from the participants' point of view, ethnography requires trust by those being observed, since they open up their offices to intensive participation and questions. And so why do ethnography in a weather hazards context like we're doing? According to Clifford Geertz, who is one of the seminal practitioners of anthropology, if you want to understand what a science is, you should look in the first instance not at its theories or findings, and certainly not at what its apologists say about it. You should look at what practitioners of it do. And that's what we're trying to do, is understand what the practitioners in the field are doing with confidence and uncertainty. What I like about this quote is the acknowledgement that how science, including predictive science, is conceptualized, taught, and believed can be different than how it's practiced. It shows how science gets operationalized, innovated, communicated, and accommodated in different settings. So for us to understand confidence and uncertainty as these concepts and activities are practiced on the ground, it's necessary to observe these concepts in action. And what we're doing, we're calling more of a collaborative ethnography. It is an approach that involves 3 different kinds of social scientists, someone from communication, anthropology, and then science and technology studies. And as I mentioned, we're simultaneously deployed to 3 different sites. And at each site, we've developed relationships with our expert collaborators, some from past and ongoing projects over time. So this slide depicts ethnography, especially a collaborative ethnography, is messy, nonlinear, and continually evolving as relationships and research evolves. While the linear model of research would suggest we independently develop ideas, research questions, and collect data, our approach has been much more iterative at each stage. So I'd like to talk through just 3 brief elements of our collaborative ethnography that we think are important to highlight today. There are, in particular, the shared intellectual inquiry is the first one, which began with a project in our proposal. These are the questions taken directly from our proposal. And through continued refinement and with our partners, these questions have evolved and new goals have emerged. So how are confidence and uncertainty conceptualized by forecasters and their partners for both warm and cool seasons? And then how do these concepts propagate among and between these 3 sites? That's what we originally began with. But then over time, through ongoing conversations, previous relationships that we've developed, and an iterative kind of process from event choice and timing and research questions, our collaborators have become analytic partners for us. So you can see here in the middle of this slide that for warm season, they've asked us to focus on an SPC marginal risk with possible tornadoes and widespread hail and wind. And for cool seasons, an SPC slight risk or stronger and higher tornado likelihood. This is because our partners feel that some of these might have lower or higher confidence or lower or higher uncertainty as the threats are evolving and in their communication with the public and partners. So as you can see, we need their expertise. We don't want to just parachute in with our expertise. This is part of also building work that can be moved into operations more quickly. So one of the other challenges that we wanted to highlight are the logistics of coordination, and there's really 3 of these that we've been thinking about. We're all soft-funded researchers, and so we're balancing multiple grants and multiple projects. So coordinating the calendars of the 3 social scientists along with the calendars of our 3 sites has proved to be a real challenge. Coordinating with partners who are busy with other activities beyond the grant, and there's unexpected issues that always arise. That can also be challenging. And then, of course, coordinating with the atmosphere, such as predictability of the threat. We're trying to get into the field a day or 2 before the threat is supposed to evolve so that we can watch confidence and uncertainty emerge over time. That's also posed a particular kind of challenge. So this is just an example when the grants were first awarded in 2018. We coordinated with our partners the types of threats, timelines, and interests. And we decided on the warm season deployment in 2019 in the summer and a cool season and deployment in 2020. However, in 2019, we attempted a deployment for June, but there were multiple types of busts, as I'm sure our colleagues and the physical sciences experience. We had everything from health issues and travel logistics to weather busts. So we had to move our warm season deployment to this year, and that is now COVID-19 dependent, of course. And we just finished our first cool season deployment in February. So ongoing challenges with coordination. And then finally, the most important one is ethical commitments, which we derive from some literature on relational ethics, which is a contemporary approach to ethics that situates ethical action explicitly in those relationships. So if you think about ethics as a way we should live, then relational ethics is essentially about how we should live, and of course in our context, research together. And so this is a very complicated process. It goes beyond the Institutional Review Board's requirements of ethical standards, which at a minimum ask us to get consent and ask us to protect the privacy and anonymity of our participants. But this is really iterative and recursive going on throughout the project. It's emergent and complex. And one way we like to think about it is not just a study of groups, but with groups. So another way to frame this is not so much O to R to O, operations to research operations, but operations with research with operations, and thinking about the individuals in this process too, not just the groups with which they represent. And so how does this materialize as ethical activities and approaches? Partners take the lead on problems, on outcomes, and on ethics. So they become, as I said, our analytical partners throughout this entire process. We iterate on goals and outcomes frequently, which helps us develop trust over time, but also ensures that as we discuss these emergent findings, we have this O with R with O at every step. And this helps our partners then take actions that can change their operations more immediately, but also think through longer-term goals that they might have and that we can help them with, and that helps build our knowledge as researchers too. And so implications here, I'll quickly just say that this is taken from the National Academy's Consensus Study Report, and that one of the needs that we have as social scientists is different scopes and budget sizes to accommodate these research needs, especially interdisciplinary work that is for research-intensive data collection like ethnographic studies. And so those needs more broadly might be making space for more of these intensive research approaches because there's so much to be gleaned from them. It also acknowledges that we need forecaster and partner expertise. It's difficult to do this work, especially as soft-funded researchers, so we could use bigger pots or different pots of money that are commensurate with this kind of work. So if you have future questions about this method, please give us an email or feel free to raise those questions here today. Thank you.
All right, thank you very much. All right, next we'll turn it over to David Dubois.
Well, hello, this is Dave Dubois. It's a good morning or a good afternoon, depending on your time zone. So I'm going to be talking about science clears the air in dust storm response. Let's get started. So first of all, I just want to mention that this project comes out of the CLIMAS RESA program. It's the one that's in Arizona and New Mexico, as shown in that map. It's a two-state climate assessment for the Southwest. There it is. And basically our mission with CLIMAS is to help communities in the Southwest U.S. respond to climate events, climatic events, and climate changes. And there's our website. And it's like I said, it's a two-state RESA with University of Arizona and New Mexico State. And there's a great group of people working with here in CLIMAS. As you can see, it's 20 years old, has a diverse interdisciplinary research team. And our current program theory is ongoing interactions between CLIMAS researchers and our partners. They contribute to a social learning system comprised of researchers and practitioners who collaborate to work on climate issues in the Southwest. All right, so let me get started in this what kind of project that we're working on with CLIMAS. It takes place in southwestern New Mexico. I'm based over just a little 2 hours east of this project area in Las Cruces, and the project area is by Lordsburg. It's in southwest New Mexico in the Chihuahuan Desert, and just want to make a note with kind of the climatic the precipitation ranges about 10 inches on average, and we can get as little as about 4 and even double the 10 inches on a really wet year. The areas that we're looking at are basically several dry lake beds, and the Lordsburg Playa is one of those dry lake beds. It's in a closed basin about 4,100 feet, and it covers about 100 square kilometers. So let me show you a picture. Well, first of all, let me look at the motivation for this project. So dust storms are a significant transportation hazard in the Southwest, especially New Mexico in the southwest part. We've had about 40 fatalities in here since 1965, and one particular year in 2017 we had 11 fatalities on a stretch of Interstate 10, and I just showed you 5 of those major dust storms that caused accidents, and you can see I highlighted the number of people deceased as a result of the dust storms, and some of them they range in from February through the summer and all the way through the end of our North American monsoon period, but we can get them pretty much any time of the year, although we get 2 different types, and which I'll talk about in a little bit. Here's that picture I wanted to show you. So this is a photo of the Lordsburg playa. Most of these type of playas are seasonal water coverage. This particular time of year, when I took a picture, it was no water. There can be water over this area, and like right now, we've got a lot of water on it. But as soon as the water evaporates, we can get a lot of dust production. And this picture here just shows you an example of that one particular year, 2017. I was looking at over from the overpass a few miles away, just to kind of show you what it looks like when we have these dust events. So one of the things that the project involved was working with the National Weather Service, the New Mexico Department of Transportation, and it's basically we worked on a co-production model to look at so what are they looking for, and so how do we develop a response to these dust storms to basically protect the drivers as you drive across this area. The crazy thing about these dust storms is it's unlike fog, where you can basically see where the fog is. You drive into it. These dust storms can come up almost out of nowhere and basically come up within less than a minute. It looks clear, and then all of a sudden you're in the midst of this brownout. And it's that picture that shows you in the middle is actually a screenshot from one of the police officers going through the dust storm. And this is what they see, and as you get over to the right is a truck. So we're looking at different types of phenomena and working a lot with the National Weather Service office here in this area in Santa Teresa. We've categorized them from local scale, which goes all the way from dust devils all the way to microbursts, and to larger scale ones, to local regional scale, convective outflow from large groups of thunderstorms, all the way up to cold fronts, the synoptic scale type of storms. And so that we were trying to reason through kind of what do we do and how do they come up. And so our collaborations that we put together, like I mentioned, with the Department of Transportation here in New Mexico, the National Weather Service Forecast Office locally here in it's called El Paso, but it's actually in Santa Teresa, New Mexico, and then working with Bureau of Land Management, the NRCS, Natural Resource Conservation Service, and a local trucking company, Mesilla Valley Trucking, as well as our state environment department, New Mexico Environment Department, and USDA Jornada Experimental Range. Those are our partners in this project. And so one of the parts of the project involve installing more warning devices to look at the dust strength, duration, intensity, timing. Just shows you one of my students. So a lot of what we do is bring students on, train them with our CLEMAS funding, basically creating new opportunities. And so one of the other things is putting together a time-lapse camera network, and basically we have a bunch of these out there collecting image every 5 seconds, so basically creating little movies. We've got almost 5 years of data. And it's one of our students is also putting together machine learning methods to classify events. So that's one of the tools that we created over for this project. And just to show you the collaborative monitoring we have in across, this is the light colored area is the Lordsburg Playa. That the line that goes through diagonally is the Interstate 10, and then all the little the stakeholders are noted in that graph, in this map, showing where the roadway information system for NMDOT and then ours coincide. So there's basically a collaborative atmosphere here for advanced warning and tracking dust plumes. And some of the actions that we're doing over on that left side of this slide are some of the things that we're doing right now or are completed in terms of hazard mitigation as a result of our teamwork. Looking at increased number of warning signs. If you drive through there, if you're on I-10 on the very western side of New Mexico, you'll see a lot of warning signs to tell you what the hazards are. And then the NMDOT has put together an increased size of the shoulder so that you do have an option to get off. And then putting together, including them, us in our putting together more dust monitoring out there. And currently what they're doing now is mitigating the dust sources. And that's an ongoing thing, as well as the truck driver education for trucks, for the various trucking companies. And then over to the right, the recommendations that we're having to present to them basically is, on-site visual observations are basically the key. The ply is always going to be there, and we're trying to figure out ways to minimize the hazard through letting people know of the hazard and giving the police officers a warning so that they can also, so basically they know what to look for. And then also passenger vehicle education. We've had some success in that with our university. When you get a permit for driving a university vehicle, you have to pass basically a bunch of questions, a test, and one of the questions, a couple of the questions on there are for dust storms. So that we got that in there so that people know about them. If they're going to be driving a vehicle, there's going to be if they're out in that area, that's one of the hazards. And then one of the other areas looking at is more increased dust monitoring along the highways, and that's going to be another partnership with multiple agencies to increase that and to find out what are the funding avenues that we can actually do this successfully and sustainably over time. And then, for instance, like one of the other ideas in kind of following on with Arizona, with the Arizona DOT is putting another radar potentially, having other options for more advanced notification. So one of the takeaways that we have is NMDOT has put together a warning. What do you do when you come across dust storms? It's called Take 5, Stay Alive. It's just 5 steps to actually do when you come across. And we put these, they put them on, NMDOT put them on the dynamic messaging signs throughout New Mexico. So there's a lot of education going on to let our people who drive through and the people who live here know what actually to do. So I just want to acknowledge all of our partners. First, CLEMAS for supporting our graduate students here, NMDOT for funding for instruments, and then a great partnership with the National Weather Service Forecast Office in Santa Teresa, helping out with social media as well as meeting and talking about the different types of dust storms. And also acknowledging our local BLM, Bureau of Land Management office here for coordination, and as well as NSF funding for some of our grad student work. And then there's a list of students and staff there to help out with time-lapse cameras, which is it's pretty much our mainstay for longer-term monitoring here. It's been very, very helpful, and I'm very appreciative of everybody who's contributed to that. And my last slide is my contact, to show you a picture of one of those. This picture there shows actually a wet microburst. We've had a lot of those who are dry, and then you can often with these you see a dust foot come across as a leading edge of the wet microburst. So you get hammered with a dust storm and then hammered with rain sometimes, but a lot of times we see without the rain. So you can also follow me on Twitter at NMClimate for more information. I really appreciate you listening in. Thank you.
Thanks, Dave. Next up is Kara. Kara? You're going to need to unmute. Hold on, we're waiting for Kara. Kara, can you hear us?
Okay, can you hear me?
Yes, sound good.
Okay, great. Hi, this is Kara Salazar. I'm really happy to be here to represent Tipping Point Planner, the program, as well as the team. And to get started, I'll tell you a little bit about the Tipping Point Planner program. This is a true collaboration between scientists, extension professionals, and community leaders. We've collaborated to apply cutting-edge research to solve community issues and problems. This is a long-term collaboration. We've had 25 researchers from 7 institutions working on this project. And this is also a Great Lakes-wide focus. So all of the tools and resources I'll show to you today do work in each of the Great Lakes states. We have also included coastal community development specialists and pilot programs from all the Great Lakes states as well. We did conduct a formal needs assessment, collaboratively developed tools with our stakeholders, and of course conducted the pilots to address the needs of the users. This is a NOAA and multi-agency supported effort. We have funding through the Great Lakes Restoration Initiative and NOAA, at least for the next 2 years. This demonstrates the wide-ranging collaborators representing the work with Tipping Point Planner through state and federal government agencies, universities, non-government agencies, land grant extension, as well as sea grant outreach. We created Tipping Point Planner to identify ecological tipping points. So these are changes in the condition of the environment that are difficult or impossible to reverse before they have been reached, instead of reacting to issues after they've occurred. Our ultimate goal with this program is to protect and restore watersheds in the Great Lakes region. So we have worked with key partners and stakeholders to identify several challenges affecting water quality. And these include nutrient loading from agriculture and urban landscapes, land use changes, such as increases in impervious surfaces, and stream webs and food web health. This is a listing of the 6 main topics that we have identified through our partnerships to work with the Tipping Point Planner Decision Support System. The stream health modules utilize current and future projected stream health scenarios. It uses the index of biotic integrity scores correlated to land use stressors that indicate stream health, such as % urban land cover, % suburban land cover, % ag land within a 150-meter buffer of streams. And with the food web modules, we're examining impacts of increased nutrient loads on the food web of Saginaw Bay. So users can view changes in biomass of walleye, yellow perch, aquatic plants, and harmful blue-green algal blooms when with phosphorus concentrations are increasing or decreasing. And in the nutrient loading modules, this provides a comprehensive view of nitrogen and phosphorus quantities, including sources and watersheds. We have 2 primary types of models that we use. There's the spatially explicit nutrient sources estimate, map, and model. This focuses on hydrologic unit code 12 watersheds in the Great Lakes Basin. And there are 7 distinct nutrient sources that it's focusing on: atmospheric deposition, point sources, confined animal feeding locations, septic systems, non-confined animal feeding operation manure, golf course fertilizers, nitrogen fixation, and chemical ag fertilizers, as well as non-ag fertilizers. And this displays annual applied loads for Huck 12 watersheds with % contribution of each source. We also utilize the Spiros phosphorus loading model, and this is for current and future phosphorus loading. This is the USGS model. It combines water quality monitoring data with information about landscape and predicts nutrient loading levels transported by rivers and streams. And this looks at 6 sources of phosphorus at the Huck 8 scale, or hydrologic unit code 8 scale, for point sources, urban land uses, manure from confined and unconfined animal sources, farm fertilizers, and forested land uses. And with our land use change modules, we can look at past land use, and this past land use feature examines how land use has changed between 2001 and 2014. And our future land use feature uses the land transformation model to predict land uses in the next 10 to 50 years. And then with the green infrastructure modules, we utilize the long-term hydrologic impact assessment module, and this looks at estimates the impacts of land use change on surface runoff and non-point source pollution. And we have a paint scenario tool where you can change land cover types and calculate the impact land use changes have on pollutant loading. And we have several different common non-point source pollutants from urban areas represented. And then finally, we do offer some limited features for Coastal Wetland House, although we are updating that one and we'll have more features available in the future. The decision support system has 3 different scales that we use for planning and information delivery. At the regional scale or the basin scale, we're looking at planning aspects that impact the Great Lakes. At the watershed scale, we look at HUC 8 and HUC 12 scales for statewide uses within each Great Lakes states. And at the county level, we have county planning dashboards and data snapshots for all counties within the Great Lakes states. And you can learn more and access this at the website located there. We have 3 different overarching aspects to the decision support system. We have the community information overview, which shows current and, land use as well as environmental assets and threats. We also have the tipping points and indicators modules, which is the majority, includes the majority of the models that I just mentioned, and these include interactive maps and tools to identify land use limits and critical areas for protection and restoration. And then finally, we have community planning tools, and these are the scenario-based planning with the paints tool that I mentioned earlier, where you can draw new land cover types and visualize impacts of land use changes. Although we have several different features online, we also use this as a community engagement program. So we want to enable diverse stakeholder participation in land use decisions and management strategies. You can see several of the target audience examples there, and the projects that we work on are watershed management plans and comprehensive plan updates. This graphic represents our community planning overview, and it demonstrates the collaborative process we have for identifying issues to address and action planning. We don't work only top-down or bottom-up, but very much collaboratively between the Tipping Point Planner team and local community leads and stakeholders to go through a planning process. And our action planning process format follows community development best practices for strategic planning and community engagement. We have several different types of meetings, including coaching through a steering committee, working through visioning workshops, and then we coach quite extensively using the decision support system through working group meetings until we get to a final action plan for use with one of the planning outlets I mentioned earlier. The action plans consist of all of the data, maps, and graphs that have been compiled through the decision support system. We also have things like action registers and tailored strategies for use within your local planning needs. Some example communities that we've worked with in the past couple of years are listed here. In Augrey, Michigan, we worked in the Saginaw Bay watershed. This was a watershed management plan and worked through several different types of green infrastructure implementation projects with Michigan Sea Grant, Michigan State Extension, as well as Huron Pines nonprofit organization. In Perrysburg, Ohio, we worked in the Maumee watershed for a city comprehensive plan update and their land use planning effort, and we worked with Ohio State University Extension, Ohio State Sea Grant, as well as Reveal Consulting Firm. In Peoria, Illinois, we also collaborated with the city's innovation team to help them through their green infrastructure planning and modeling to address combined sewer overflows. We went through the planning process of Tipping Point Planner and then also helped them with some detailed modeling within their sewer shed for green infrastructure placement. We're continuing to update the tools and creating some additional programs for on-the-ground planning. We're happy to work with communities across the Great Lakes. We can work in person as well as coach you and train you to run the program on your own. We did have a workshop coming up in March, but that has been postponed, of course. And you can also learn more through information on our website. We have a lot of reports, fact sheets, and videos to learn more. And we have a great article in Esri News through winter 2020 edition. And it's titled, "With GIS, Communities See How Land Use Changes May Affect Local Water Quality." And thank you very much. I'm very happy to have additional questions and through my email here too.
Thank you, Kara. Take it away, Alan.
Hi, I'm Alan Haney. I'm an economist at NOAA Fisheries Alaska Fisheries Science Center and the Office of Science and Technology. So I'm based in Seattle, and I'm going to talk about how we combine social science with data and statistical tools to improve marine protection and fishery management. And a key message really here is that this type of social science really can make a big difference in allowing us to get more benefits from our oceans and coastal resources, whether you're focused more on preservation or communities and fisheries and seafood and food for Americans. In any case, you want to do this well and use science to effectively manage our resources. So one key thing that we see is that fish and marine mammals, so they vary in abundance from year to year and within years, and they move around. So fishers move around also to try to find the best places to catch the things they want and avoid other species that we're trying to protect. So there are a number of different data sources that we at NOAA Fisheries and various other NOAA and federal agencies and state agencies collect that we can integrate and use statistical models to help us do this process better. And this lets us, as I said, work on how do we make these trade-offs that are challenging of using these resources with the most information for decision makers to make those trade-offs and transparency for the public about the impacts of different management choices. So NOAA makes lots of different types of predictions. So the Weather Service makes hurricane forecasts. We in NOAA Fisheries make lots of go out and we do sampling in different areas, or we use onboard observers or self-reported data from vessels to estimate the fish populations that allow us to determine how we can sustainably harvest fish that becomes seafood that we eat. What we'd like to be able to predict better is to understand how both environmental changes and changes in policy and management affect what fishers do and the impacts on communities where the fishers are based. And for all of us who consume seafood and who value marine resources wherever we are. We may be in Detroit or Kansas and still care about preserving fishing communities and marine mammals or turtles. So in some cases, we are focused on trying to estimate the fish stock biomass best and then see how fishers are going to respond to that. And then an increasingly large issue with climate change is that some species are moving either across state boundaries, as is a significant management challenge on the east coast of the United States, or across national boundaries, either from the United States into Canada, or in some cases back and forth, stocks that are moving out of U.S. waters, or in where I work in the Bering Sea, also some of the fish are in Russian waters. So what the work that's described here is work that we've done where there are onboard observers on some vessels. So a lot of our large fisheries in Alaska have 100% observers on them, as do on the west coast of the United States and some select fisheries around the country. But other fisheries have a really small amount of observed fishing. But a number of vessels have vessel monitoring systems or automatic identification systems, DMS and AIS systems, that give information about where the vessel is and how fast it's going, how far it is from port. So we can combine these data in statistical models and then accurately determine where fishing occurs, even when we don't have observers on board. And this is just one example that the arrows here show the observations that come from vessel monitoring systems. These systems vary in how frequently they transmit positional information. It can be multiple times per minute or several times per hour or once an hour. And we're able with this to look over time and combined with the observer data where we know that they're fishing at certain points, identify the behavior that with a high degree of confidence suggests that they're fishing. And this has really improved our ability to understand where the valuable areas for fishing are. So this is looking at the Gulf of Mexico, and you can see those large boxes like on either side of Florida. Like there's 7 areas along the west coast of Florida at the level that vessels self-report their data. And then you can look in the lower plot how there's much more detailed information that comes from our analysis. So they're turtles that use small areas to, that we'd like to protect, but we don't have the detailed information from the self-reported data on where the fishery is focused. So this greater scale that we're able to use by integrating this data vastly improves our understanding of valuable fishing areas, and we're then able to protect the right areas and preserve the valuable fishing areas for fishing opportunities. We're also with this able to look at the impacts of regulatory action, so that fishing is a really complex business, and fishery management councils and NOAA work together on state agencies as well to set up rules that try to balance the balance protection and fishing opportunities. And this lets us really see what the costs are of fishing in different places and how management and environmental change are interacting in a way that lets us design better protection and better management that is beneficial to fishers. All of this information we're using the outputs from these analyses in a variety of ways. We're setting sustainable fishing quotas in a more effective way. We're protecting different species at a lower cost, and we're better understanding the impacts of climate change. And ongoing support is needed to make sure that we can do this throughout the country. We've been able to do this in select fisheries, but there's a lot of work that still needed for us to do this. There's a tool that we've been working on that we'll release later this year, the Spatial Economic Toolbox for Fisheries, that allows different analysts to do this more effectively and to look at the impacts of different management actions on fisheries. So throughout NOAA Fisheries, we're working to build these types of tools in different regions and with diverse partners to improve management and protect coastal resources and provide more opportunities for communities. And I just want to say thanks to all of our supporters and collaborators. This is work based on things that I've done with many people. Jordan Watson, who was a PhD student at the University of Alaska, is doing some great ongoing work tying this type of analysis to satellite data. These are a number of the people who are key players in this work. So thanks.
Thank you, Alan. And we've finished our all 4 of our presentations, so you're welcome to ask questions now of either Dave, Jen, Kara, or Alan on any of the topics. And we did have a comment from Alberto who said, excellent. I think he was referring to one of the slides that Alan was talking about. I think it was this one, right, Alan? Or Alberto? So folks online, if you have any questions, now's the time. We have several questions, it looks like, coming up. While we're waiting for the questions, you can see this is the link to the full 2019 NOAA Science Report, and I've posted, or Emma's posted it earlier up on the chat if you want to download that. So we have a question from Yvonne who asked, Tracy, how do you motivate, oh, it's not me, but probably to somebody else. Tracy, how do you motivate stakeholders to participate when they are hesitant? I think that's a question for somebody else. Maybe Kara? Or Jen?
Hi, this is Kara. I can certainly address this one, and then there's another one too for Tipping Point Planner. Were there any surprises working with the community? So my work spans across community development and planning, and the teams that I work with do a lot with with facilitation too. So we have a lot of strategies that we can use, and that's where we feel is this unique aspect of Tipping Point Planner. We have this fantastic portal for research and models, and then our groups can come together to conduct community development and community planning processes to engage a broad, diverse group of stakeholders. And so we try to, we have several different types of techniques for breaking up power components, as well as reaching out to groups in different ways. So we may go to, in addition to having a community forum, we may go to another place and have a feedback mechanism where they can talk more one-on-one with people as well. And as far as surprises, we usually some of the surprising things are the groups that do work together at the end of some of these efforts, so that they do have a diverse group that are providing feedback on things that perhaps hadn't been considered before because either they hadn't been asked or they didn't have the opportunity to be connected with different types of agencies that may not have worked together before too. So many times, I know that's a little general, but those are some of the highlights that we see, that getting to know community is very important.
And then we have oh, go ahead.
And then one last thing, can we provide services outside of the Great Lakes? So we, our Tipping Point Planner works in Great Lakes states. And then we also have other types of tools and techniques and programs that can work in communities throughout the U.S. and through our extension networks, we can certainly support that too. So I'd be happy to talk to you more if you'd like to shoot me a note.
Thanks. And now Yvonne says, in the time of COVID-19, how can you keep the momentum going? I guess that's Kara, that's a question for you. Did you already address that?
Yeah, this is difficult because we are postponing our community in-person forum. Some of these things are difficult to do online, but for some communities we're working with, we are moving forward with our community-based surveys, and we have some focus groups that we're going to try out online. So we're trying to adapt to these changing times, and we'll figure out how these things work, but we like to do things in person as much as possible and hope to get back to it very soon.
Okay, thanks. And then I had a question. Alan, can you tell us a little more about the tool that's you're in planning, FishNet? And is that going to be for
it's FishSet, actually. Yeah. Yes, it's something that we have pilot projects that are operational around the country that are different stages. And this is something that I've been working on for several years. And it's trying to basically take a number of models that have been used in a relatively academic sense, where they take a long time to update, and people have done nice analysis to understand how fishers behave on the grounds and the types of things that are important, how they trade off different amounts of fish with different distances from port, or different interactions with bycatch species. And we'd like to do this better so that we can then build a management system that really takes into account what the user's needs are, and can protect the things that we need to protect, but do that at the lowest cost possible. And also allow us to make trade-offs, like in New England, where there are a lot of wind farms or wind power areas that are being implemented to try to set up the balance between that and fishing needs. This is the data that involved in this is confidential data that's reported or estimated, from the fisheries, but different researchers have access to this, and the tools for this will be released. We've have different pilot versions, but we'll distribute this so that different analysts can do this around the country. And the goal is to have standing models of the different fisheries around the country, so that when different managers want to make rules, they can use those models to make the best and least costly rules that they can.
Okay, thanks. And you have a follow-on question from Gina. For Alan, is there any way the data is or could be used to identify illegal, unregulated, or unreported fishing?
Yeah, good question. There are a couple things. So the AIS systems are on a lot of vessels, and there's several private companies that are doing this a lot on the open oceans to try to do this. There's another system that's called Hawkeye 360. That's a new system that where you can see vessels even when their AIS is off. So this is there's been a lot of progress on this, and I think in the next few years we're really going to be able to do this well collectively, and so that I think we're going to see most activity and just trying to understand the subtle signatures of their behavior when, for example, they've been fishing and then they go to offload fish to a transport vehicle. We'll be able to see that activity and then take action on it.
Okay. Thanks, Alan. Devin asks, hi, Alan. Thank you for your presentation. Is it challenging to implement sustainable harvesting in fisheries that are more focused on the short-term goal of making a profit?
Thanks, Devin, for the question. In the U.S., we have quite good regulation of fisheries, so that we're carefully monitoring where they are, where the Office of Law Enforcement goes out and hops on vessels and makes sure they have the permits and things that they need to do that. So I think there certainly are things that we're not seeing, and your question is a good one, that people are trying to make money, but at the same time they understand the consequences to actions, and we work hard to work with fishers to make those rules tolerable and effective.
Okay, and I think we have maybe one more question from Gina, and we'll wrap it up. Oh, a couple, that's fine. Gina asks, regarding the dust storm images, how do you keep the cameras free from dust so that they can take pictures?
Yeah, thanks for that question. Really good question. We have basically they're just trail cams, basically kind you go over and you buy for hunting, and they do get quite a bit of beating when they're out there in that kind of environment. So yeah, we have to go out there every few weeks, every 3 weeks, and clean the optics, and so that we can actually see anything out of those. So yeah, it's a challenge. I mean, it's actually hard on all the instruments out there. It's sort of sandblasting environment. Yeah.
Okay. Yeah, I can't imagine how dry it is out there. Oof. So Devin says thank you, and I think that's about all the time we have. Emma's going to do a little wrap-up for us.
Thank you, Tracy. All right, so first I want to give a big round of applause and I guess remote thank you to all of our speakers today who took their time to come and talk to us and share their really exciting work. So thank you, everyone. We appreciate it. Yes, clap, clap, clap. All right, so like I mentioned at the beginning, this was the fourth and final seminar in our series to share more about the 2019 NOAA Science Report. We want to thank everyone who participated, who presented, and also all of you who attended. So a big thank you. We appreciate your participation. We hope you've learned a lot and been excited about these topics that have been covered. So I think that's about it. Just want to say a big thank you. All right. Oh, and thank you especially to Tracy, who has coordinated all 4 seminars as part of this series. She's been really fantastic, and we appreciate her coordination.
Oh, and I will go right back to Emma and Gina DiGiantanio and Laura Newcomb. They put this seminar series together. They're the ones who put the report together. So thanks again, you guys, for all your hard work. And presenters, thanks so much for taking the time and effort to present today. And if you want to get a copy of any of these MP4s or PDFs, you can contact Emma, Gina, Laura, or myself at the emails listed. Thanks for joining us, everybody. Bye-bye.
Bye.